Hello children, let's come back to our maths class. Today we are going to continue with our exercise 7.2. In the previous class we have completed till sum number 18. Today we are going to continue with our sum number 19 from exercise 7.2. So get ready with your classwork. Take down your classwork and write down today's date. Take down your classwork, write down today's date and copy down question number 19. Copy down question number 19. Copy down the question. Determine the roots of the equation. They have given you one determinant. It's 1, 4, 20, 1, minus 2, 5, 1, 2x, 5x square is equal to 0. So this we have to find out the root of this particular equation. Okay, so we have to find the roots. That means we have to find out the value for x. Okay, so this is the determinant and this is equal to 0. Let's see how to simplify this further and get the value for x. Copy the question properly. Just write down all the elements properly. Do not make mistake when you copy the elements. So I get determinant of 1, 4, 20, 1, minus 2, 5, 1, 2x, 5x square is equal to 0. Have you copied the question? Okay, now let's see how to simplify this further. Okay, let's see how to start this up. So now what we are going to do here, we are just going to make some row conversion. We are going to change R1 as R1 minus R2 and also we are going to change R2 as R2 minus R3. This is the changes that I am going to do. I am going to change R1 as R1 minus R2 and I am going to change R2 as R2 minus R3 and I am not going to do any changes to the third row. Third row is going to be as it is. Okay, now let's see how is the change occurring over here. So R1 is going to change as R1 minus R2. So take the corresponding element. See, so 1 minus 1 will give you 0. Then 4 minus of minus 2. We have to subtract. So here already minus sign is there. So 4 minus of minus 2 will give you 6. 4 minus minus 2 gives you 6. Now this is 20 minus 5. 20 minus 5, 15. So I have completed the first row. So I got new elements now. See, first it was 1, 4, 20. Now we have 0, 6, 15. How you have found this? R1 minus R2. So 1 minus 1, 0. 4 minus of minus 2, 6. 20 minus 5, 15. Okay, so now we are going to go for the second conversion. We are going to change row to, let's see how to change row to R2 minus R3. But R2 minus R3 means this two correspond. So 1 minus 1 will give you 0. Minus 2 minus 2x. Minus 2 minus 2x. This is 5 minus 5x square. Here we don't get any value. Just write down the equation in form of equation. So minus 2 minus 2x and this is 5 minus 5x square. So we have changed the second row also. Third row we are not going to do any changes. So the third row will be kept as it is. So I get here 1, 2x, 5x square. So I have written all the members of all the rows. So now let's see here how to do the sum. See down here we have two zeros. Yes? So I'll just draw a line here. See, like this. So this is 0, 0. I'll neglect this part and I'll neglect this part. So only I have to take 1 here. So once since the number is 1, there is no need to worry about 1 because anything multiplied by 1 will give you the same answer. So what you have to do is you have to just cross multiply these two values. Neglect this 2, 0 and neglect this. That is, neglect the first column and the third row. We have to consider 1, but 1 multiplied with any other number will give you the same answer. So do not write 1. We can directly take the cross multiplication of these numbers. So I get 6 into 5 minus 5x square is equal to 15. Actually get this done. 6 into this. The main side will be minus 15 minus 2 minus 2x is equal to 0. You want to take out the steps? I get 6 into 5 minus 5x square minus 15 bracket minus 2 minus 2x is equal to 0. Now we have to just open the bracket. Let's try to open the bracket. I hope you are clear with the steps. Since we have there 2 zeros, we are just neglecting that row and column. That is, that first column will be neglected. Don't take 0, 0 and do not take the last row. Only we have to take 1. But the 1 doesn't make any difference. It's like this, 1 into something. So 1 into something is going to give you the same answer. So I have not taken 1. Okay, so now let me open the bracket. So I get 6 5s are 30 minus 30x square. 6 5 is 30x square. This is minus 15 into minus 2. Minus 15 into minus 2. So minus minus plus 30. This is minus 15 into minus 2x. So I get here plus 30x because minus 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 plus. So we get here plus 30x is equal to 0. I get 30 minus 30x square plus 30 plus 30x is equal to 0. So now we are just going to arrange in a proper order. So I get this as minus 30x square. I will take according to the highest power. Okay, so first x square, then I will take x, then I will take 0. Like 1. So now this is 30x square, then what I will take here? 30x. So 2, 1, then next I will take 0. So 30 plus 30 will give you 60. Is equal to 0. See here? I get minus 30x square plus 30x plus 60 is equal to 0. I will divide all the terms by 30. So I get this as minus x square plus x plus 2 is equal to 0. I get minus x square plus x plus 2 is equal to 0. I don't want the first term to be negative, so I will change all the signs. I get here x square minus x minus 2 is equal to 0. So we have found one equation. Now using this equation, we are going to get the roots for the equation. So you can use the quadratic formula method, or you can use the t method to get your answers. I will take the t method. On the top of t, I will write minus 2, and on the bottom of t, I will take minus 1. Minus 2, minus 1. Okay. Now take the factors. So I can write this as 2 into 1. I want minus minus on both sides, so take the bigger number as negative. So minus 2 into 1, minus 2. Minus 2 plus 1 gives you minus 1. So what are the variables here? X is the variable. So I get the answer as x minus 2, x plus 1 is equal to 0. I get x minus 2 into x plus 1 is equal to 0. So the value for x is equal to 2 or x is equal to minus 1. So these are the roots of the given equation. Just write the answer. Therefore, x is equal to 2 or x is equal to minus 1. Complete the work. I hope you are clear with sum number 19. Okay, now coming to the last sum of exercise. Yeah, we have 2 more sums. Yes, 20th sum will be your homework. You know how to find out determinant part. So just complete sum number 20 as your homework. And now we are going to go for the last sum of the exercise, that is sum number 21. So copy down question number 21. Copy down question number 21. Using cofactors of elements of second row, evaluate determinant of A where A is equal to 5, 3, 8, 2, 0, 1, 1, 2, 3. So they have given a matrix A. So we have to find out determinant A using the cofactors of elements of the second row. Copy down question number 21. So A is given to us. The matrix A is 5, 3, 8, 2, 0, 1, 5, 3, 8, 2, 0, 1, 1, 2, 3. So this is matrix A, okay? And they are saying that you have to use the cofactors of elements of second row. Only they are asking you to focus on the cofactors of second row, and we have to find out the value for determinant of A. Now let's see how to start this up here. So I am going to use this second row. Using second row, I have to get the answer. So first of all, I will take a cofactor of this. I will write down here A. This is second row, first column. So I write A, 2, 1. What is the meaning of 2, 1? Second row, first column. So what is the element here? 2. So what you have to do is you have to just neglect this. And you have to neglect this. Second row and first column you have to neglect. A to 1 means neglect the second row and the first column. So what is left now? 3, 8, 2, 3. So you can just write down this as 3, 8, 2, 3. I have taken the determinant form. So the answer is 3 3s are 9. 8 2s are 16. So 9 minus 16 gives you minus 7. Okay, I have found the answer for A, 2, 1. That is the cofactor of the second row, first element. Clear? Now we will go for A, 2, 2. See how to find out A, 2, 2. A, 2, 2 means you have to neglect second row and second column. So what is left now? 5, 8, 1, 3. That's 15 minus 8 is equal to 7. 5 3s are 15 minus 8 is equal to 7. So I have found two cofactors. One is A21 and also I have found A22. Okay, now we will go for the next one. Now we are going to find out A23. That is the second row, third column element. So what is A23 here? A23 means second row and third column should be avoided. So I get A23 is equal to, you have to use only capital A, okay, don't use small. So A23 is 5, 3, 1, 2. A23 is 5, 3, 1, 2. So this is 10, 5 2s are 10. 1 3s are 3. So main sign is minus, so I get the answer is 7. So I have found the answer for A21, A22 and A23. Okay, completed children. Now let's see how to proceed further. So now you write down here, therefore, determinant of A. This is the formula, okay, for determinant. So you are talking about the second row. So we are going to only take the second elements. Second one is, this will be A21 into A21 plus A22 A22 plus A23 A23. This is how you have to use the cofactors of second row. So all we are talking only about the second row element. Second row first column, second column and second row third column. So I get A21 into A21 plus A22 A22 plus A23 A23. Now we know all the values, so we are just going to substitute the value and we are going to get the answer. Let's see how to substitute this. See here carefully. A21. A21 means the second row first element. What is the answer? 2. So just put here this is equal to 2. And what is the value for A21? It is minus 7. So put here minus 7. Okay. Now A22. So it is 0. The second row, second element is 0. So put here 0 and A22 is 7. So you can just mention here 7. A23. So second row, third element, that is 1. So put here plus 1 into A23 is 7. So this is equal to minus 14. 0 into anything will give you 0 and 7 into 1 gives you 7. This is minus 7. So we have found the answer for determinant of A, that is minus 7. Complete the answer. Just see here, we have to just add one more detail over here. We have just found what are the elements. Like we have to see second row and the first column is negative. So we get 2, 3, 8, 2, 3, and along this we have to just add one more thing. When you are finding cofactors, what you do is you have to add here minus 1. That is, you have to multiply with minus 1 raised to, see the numbers here, 2, 1. So you have to take here 2 plus 1. Okay, we have to just see this step also. When you have cofactors, you have to multiply with this. So minus 1 the whole raised to 2 plus 1. So it is 2 plus 1, 3. So minus 1 the whole cube, minus 7. That means what is the answer for this? This is minus 7. And along with minus 7, what are you going to do? You are going to add this minus 1. So minus 7 into minus 1, it gives you plus 7. So the answer is plus 7. So for this step, you can just have here minus. You clear with this step, children? See carefully. So A21 is determinant of 3, 8 to 3 minus 1 the whole raised to 2 plus 1. So I get the answer is 9 minus 16, and here the answer is negative. So I have to put minus, and I get minus of minus 7, that is plus 7. Now here, this will be minus 1 the whole raised to 2 plus 2. So I put here 2 plus 2. So 2 plus 2, it is positive. So no need to worry, the answer will be as it is. It will be 7. Okay. Now coming to 2 plus 3. So what I get here? Into minus 1 the whole raised to 2 plus 3. So 2 plus 3 means 5. That means I have to include here minus. So this becomes minus 7. See here? Yes. So now here we have to make small changes. So this is plus 7. And this is minus 7. I get 2 into 7 plus 0 into 7 plus 1 into minus 7. So this becomes plus 14 and this is minus 7. 14 minus 7. So the answer is plus 7. Therefore, determinant of A is equal to 7. So we have found the answer for determinant of A, it is 7. Just make the changes, children. For A21, along with the determinant, we have to multiply by minus 1 the whole raised to the number of rows in the column. So it's 2 plus 1 for the first one, then 2 plus 2 for the second one, and 2 plus 3 for the third one. If it is odd, we will get a negative answer, and if it is even, we will get a positive answer. That is, the power will become, if it is minus 1 the whole raised to 3, that means you will get a minus answer. If it is minus 1 the whole raised to 2 plus 2, that means you will get a positive answer. Minus 1 the whole raised to 2 plus 3, that means minus 1 the whole raised to 5, that means you will get a negative answer. So accordingly, we have to substitute the value and we have to get the answer. So this was about the second row evaluation. If you are talking about the third row evaluation, how you get the answer? A31, A31, A32, A32, A33, A33. According to the question, you people have to take the values and you have to get the answer. So this was our sum number 21, the last sum of exercise 7.2. Now, we are going to continue with exercise 7.3, but before going to 7.3, we have some points to be taken down. So we will take down the points and then we continue with our sum. Okay children, so take down the heading as points to remember. Take the heading as points to remember. Take the heading as points to remember, and you are going to refer page number 30 of your maths textbook. Take page 30 of your maths textbook and write down the point. Write down if our rows or columns are identical in a determinant of order n, where n is greater than or equal to r, when we put x is equal to a, then x minus a, the whole raised to r minus 1 is a factor of determinant. X minus a, the whole raised to r minus 1 is a factor of determinant. Let's see here what is the meaning of this points. Suppose you have some determinant. Okay, we have a, and here how many rows are identical? 3 rows are identical. Okay, so 3 rows are identical means, and suppose we are saying that we have first it was x, x. Now what we have done? We have taken x is equal to a. So I got a. So here how many rows are identical? 3 rows are identical. So what is the factor for this particular determinant? See it. If rows or columns are identical, if it can be any number of rows or any number of columns are identical of order n, some order is there of n, then if you put x is equal to a, then you have to say that x minus a, the whole raised to r minus n is a factor. So now here I have put x is equal to a. So what is the factor now here? X minus a, r minus 1. R minus 1 is, this is 3. How many rows are identical? 3. So 3 minus 1. So I can say that x minus a, the whole square is a factor of determinant a. So this is how you have to use this point. So remember, if you have any number of rows or columns to be identical, then you have to just use this formula, x minus a, the whole raised to r minus 1. R minus 1, and here 3 rows are same, so I will put 3 minus 1. If 2 rows are same, 2 minus 1. Okay children, accordingly you have to put and you have to get the factor. This is one point. Here some more points. Then point number 2. You can refer page number 30. You have to take on the 5th point from your page 30 under note 7.10. You have to take down the 5th point as point number 2. Write on the 5th point, if the determinant is in cyclic symmetric form, if the determinant is in cyclic symmetric form, and if m is the difference between the degree of the product of factors and the degree of the product of the leading diagonals, and if m is 0, then the required factor is a constant k. So now we should know how to use this points. Okay children, so when we do our sums, we'll be using all these points. So you should know what are the points that can be used for factor theorem. So just write down the points. If the determinant is in cyclic symmetric form, and if m is the difference, so what is here? We are talking about m only. The main thing is m, and if m is the difference between the degree of the leading coefficients, first of all, degree of the product of factors and degree of the product of leading elements Okay, so what is m here? The main thing is we have to talk about m. So what is m? M is the difference between the degree of the product of factors and degree of the product of leading elements. So this will be all new to you, and we will be using all these concepts in our sums. When we do exercise 7.3, I will explain to you what is m. Okay, what is the degree of the product of factors, and also I will explain what is the degree of the product of leading elements, because with the help of an example it will be easy to explain. So if you get the answer as 0, okay, if you get the answer of m as 0. See here, what is m? It is the difference between the degree of the product of factors and also the degree of the product of leading elements. If you get the answer as 0, you have to take the factor as k into, you just take around k and you have taken the question. So now at present you take k. So we have to multiply by k. If m is equal to 0, the factor will be taken as k. If m is equal to 1, the factor will be k into a plus b plus c. If you get m as 1, you have to take the factor as k into a plus b plus c, and if you get the difference as 2. If you get the difference as 2, then you have to take the factor as k into a square plus b square plus c square plus l ab plus bc plus ca. Right. Take down the points. So if you get the difference between the degree of product of factors and degree of product of leading elements as 0. If m value is 0, the factor is taken as k. If m is 1, the factor is taken as k into a plus b plus c. And if m is 2, the factor is taken as k into a square plus b square plus c square plus l into ab plus bc plus ca. If m is 2, then the factor is taken as k into a square plus b square plus c square plus l into ab plus bc plus ca. Okay children, so we are just going to use some of the points for our exercise 7.3. Let's see how to start with our sum. So take down exercise 7.3, copy down the first question. Down, solve the following problems by using factor theorem. So this is all related to factor theorem. The points are all related to factor theorem. Let's start the sum. Take the first one. Show that determinant of x x is equal to x x minus a the whole square, x plus 2a. X minus a the whole square, x plus 2. So we have to just use, they are asking you to solve this using the factor theorem. So we have to find out the factors and we have to simplify. Okay, so now here it is x minus a. Okay, from this I will get x is equal to, it's simple. X minus a is equal to 0 means I will get x is equal to a. So what I am going to do is, I am just going to put x is equal to a. Right up here, put x is equal to a. If I put x is equal to a, what I get? Wherever x is there, I am going to replace it as a. So I get a. This is a. Okay. So now this was like our first point. When you are putting x is equal to a, and if you get some of the rows identical. So here how many rows are identical? 3 rows are identical. So you can say for all the answers the same, I will get the answer as 0. Are you getting my step, children? So what is the first step? From here I will get the value for x is equal to a. So once I get x is equal to a, I am going to substitute in the determinant. I get a. So all the answers are same. So the answer will be 0. Now here I have to find out what is the factor. We have seen the formula x minus a the whole raised to r minus 1. So here how many rows are same? 3 rows are same. So 3 minus 1 what I will get? 2. So I can say therefore x minus a the whole square is a factor. And if you have this step, I started with x is equal to a, but now what I am saying here, x minus a the whole square is a factor. Why I am writing down this step? Using this formula. Because here how many rows are identical? 3 rows are identical. So I will get x minus a the whole square is a factor. So we have not completed our sum, we have just done half part. So x minus a the whole square is a factor. Okay, now let's go for the next factor. What will be the next factor? See the next factor? It is x plus 2a. Okay, I am just trying to get the answer from here. So x plus 2a is equal to 0. Therefore, x is equal to minus 2a. So what I am going to do is, I am going to put x is equal to minus 2a. So down here, put x is equal to minus 2a. So whenever you have x, you are going to put it as minus 2a. So I will get minus 2a, a, minus 2a, minus 2a. We cannot write down here directly 0 because everything is different. So we have to do some more calculations. Just stay on the steps. Okay, let's continue further. So what I am going to do here is, I am going to change row 1. Okay, let me see how to change row 1. So I am going to change R1 as R1 plus R2 plus R. What I am going to do, I am going to change row 1 as row 1 plus row 2 plus row 3. So what I get here, this is minus 2a plus a plus a. Minus 2a plus a plus a. What is plus a plus a? It is 2a. So minus 2a plus 2a, 0. So I get the answer here, 0. First row, first element, 0. A plus a, 2a. 2a minus 2a, 0. A plus a, 2a. 2a minus 2a, again 0. Now, write the second row and the third row as it is. That we are not making any changes. This is a minus 2a, a minus 2. Now here, since one row is fully 0, I will get the answer as 0. Since one row, this first row is fully 0, I can say that the answer is equal to 0. Here we had all the 3 rows to be identical, so I have taken it as 0. Here one full row is 0, 0, 0, 0. So I have got the answer as 0. So what we can say here, therefore, x plus 2a is a factor. Therefore, x plus 2a is a factor. X plus 2a is a factor. Okay, now what we are going to do is, see here, they are asking you to find out the degree of the product of the factor. Just see here, what is the degree here? 2. That means when I expand the factor, I get x square minus 2ax plus a square. So x square. And here what is the power for x? It is 1. So when I multiply these two factors, I get the power of x. I get the power of x is 3. That means the degree becomes 3. So what is the degree of product of factors? Degree of product of factors is equal to 3. Here x square I get and here I get x. So 3. X square into x cube. So I will get the degree as 3. Now coming to the degree of the leading elements. Here when I multiply this 3. These are the leading elements. Okay. X into x into x I get x cube. So write down degree of leading elements is equal to 3. Degree of, you can write down a product of leading elements is equal to 3. So now let me find out the difference. I have told you what is yum. Yum is the difference between the degree of product of factors and the degree of leading elements. So yum is equal to 3 minus 3. So what is the answer you are getting? 0. Yes. If you get the answer as 0, what is your constant? Constant is k. So you have to write down here. Therefore, determinant of a is equal to. So what will be the value for determinant? Here just you have to add here k along with the answer. This is k. X minus a the whole square x plus 2a. So I have to write down determinant of a is equal to k into x minus a the whole square into x plus a. Since m is equal to 0, we have to take the constant as k. Okay, now let's see what to do further. So now I have to find out the value for k. So what I am going to do is, here I will take the original determinant now. I will take value for x and I will take value for a. So take down value for x is 1. This is our assumption, okay? That x is equal to 1 and a is equal to 2. Let x is equal to, I have taken the value for x is 1 and a is 2. It's our assumption. You can just change the values also. But don't take very big values. Just try to take small values. So I will just change here 1, 2, 2, 2, 1, 2, 2, 2, 1. This is equal to k 1 minus 2 the whole square 1 plus 2 into 2. Okay, I just substituted the determinant value, a determinant, and I have taken k 1 minus 2 square 1 plus 2 into 2. Now we are just going to expand this further. So how to expand? You know, take the first element, neglect the first row and the first column. So I get 1 ones are 1, 2 twos are 4. So 1 minus 4. This is positive, then I have to take negative. Neglect the row and the column. So 2 minus 4. Plus minus plus 2, neglect the row and the column. So 4 minus 2 is equal to this is k minus 1 the whole square. I get 1 only. This is 1 plus 4. So 5. 1 into minus 3 minus 2 minus 4 minus 2. So minus 2 into minus 2 plus 4. 2 into 2. Let's simplify this further. So I get here 1 into 1 minus 1, I get minus 3. So 1 into minus 3 minus 3 minus 2, and this is minus 2. So minus 2 plus 4. 4 minus 2, 2. So plus 4. This is equal to 5k. So 4 plus 4, 8. 8 minus 3, 5. So I get 5 is equal to 5k. So 5 gets cancelled. Therefore k is equal to. So I got the answer for k as well. So I am going to replace the value for k. So I get therefore determinant of a is equal to, in place of k what are you going to put? 1. So 1 into anything will give you the same answer. So x minus a the whole square, x plus 2a. Hence true. We have just taken one statement here, determinant of a is equal to k into x minus a the whole square, x plus 2a. So here we are just substituting 1. So I'll get the thing that I have to show. The question was show that this determinant is equal to this. So I have got the answer. Determinant of a is equal to x minus a the whole square, x plus 2a. So we have proved the sum. So this was our sum number 1. I hope you are clear. When the difference between the degree of factors and the product of the leading coefficients is 0, then you have to use the constant as k. If it is 1, accordingly. If it is 2, accordingly. So here we have the difference is 0, so you have taken the constant as k. So I'll just give you one more sum for homework. You are going to complete sum number 2 as homework. This was from 7.2. 7.3, sum number 2, only one sum. This sum number 2 is based on the difference 0, okay, m is equal to 0. So you have to find out and get the answer. So we have some more sums left out in this exercise which will be continued in the next class.